I'm going to go over sections 1 and section 2. They kind of lead into each other pretty nicely. In fact, when you take the test, there won't be anything directly from section 1 on it. I mean, very, very much so, there'll be stuff indirectly on there. Even when we went over this in class, we didn't even have homework from section 1 because it just fits right into section 2, so it's kind of a combined thing. So anyway, let me go ahead and get started here. I do need to go over section 1, even though we're not going to have homework on it, because if you can't do section 1, you can't do section 2. So section 8.1 is called greatest common factor. Now, you guys have done this before, all right? So what you were used to is a question, what is the greatest common factor of, and then you'd be asked two numbers. So maybe it would be 8 and 12. Well, 2 goes into 8 and 12, but so does 4. 4 is greater, so the greatest common factor would be 4. Or maybe you'd have something like 6 and 18. Okay, there's a whole bunch of things that go into both of them, 2 and 3, but 6. 6 goes into itself, and it goes into 18 3 times, so the greatest common factor would be 6. Or we could have something like 30 and 45. Your greatest common factor would be 15. So that's the type of problem that you had seen previously to Algebra 1. So in this section, they take that same concept, but they kind of turn the volume up on it. So we're going to find the greatest common factor of not just numbers, but numbers and variables. So it'll look more like two algebraic expressions. So what would the greatest common factor of 9xy and 12xz? Well, the biggest number that goes into both 9 and 12 is 3. And then they share an x, but they don't share any other variables. So the greatest common factor would be 3x. Another example would be 4x cubed and 10x to the 5th. Okay, so one way to look at this is to sort of break it down into prime factors. So the prime factors of 4 are 2 times 2, and then you have 3 factors of x, is what x cubed means. Okay, so another way to write 4x cubed, if we break it down to factors, is 2 times 2 times x times x times x. And then 10x to the 5th would be 2 times 5 times x times x times x times x times x. Well, you can see that they share the 2's, and then they share 3 x's. So your greatest common factor would be 2x cubed. Okay, now you don't have to do that long process every time, but I just kind of wanted you to show, I wanted to show you sort of the thinking behind how to come up with it. All right, we'll try one more here. Which is, let me look at my notes here, 32x squared y to the 7th z to the 4th and 24x cubed yz squared. Okay. The biggest number that they have in common is 8. 8 goes into both 24 and 32. 2 x's here, 3 x's there, so they share 2 x's. 7 y's and 1 y, so they only share 1 y. 4 z's and 2 z's, so they share 2 z's. So your greatest common factor would be 8x squared y z squared. So again, if I broke that down the other way like I did on the previous one, 32 would be 2 times 2 times 2 times 2 times 2 times x times x times y times y times y times y times y times y times z times z times z times z. That's all the factors of that. 24, let's see, that would be 2 times 2 times 2 times 3 times x times x times x times y times z. So they share the 2's, they share the 2's, they share the 2's. They share an x, they share an x, they share 1 y, and then they share 2 z's. 2 times 2 times 2 is 8, x squared y z squared. You can see 8x squared y z squared is the same thing I came up with up there. All right, so that is a very, very quick version of section 1, which is just finding the greatest common factor. You'll notice when it comes to finding the greatest common factor of the variables, x squared, x cubed, which is the smallest, x squared. Well, that's in the greatest common factor. Y to the 7th and y. Y is the smallest, so that's in the greatest common factor. Z to the 4th is z squared is the smallest, that's what's in the greatest common factor. So finding the greatest common factor isn't too tough. So then let's look at section 8.2, which is called factoring by the greatest common factor. And I'm going to start to build this list. Now you guys have probably seen the list because you came in at the end of chapter 8, but that list is the order in which you should look to factor something. Okay, it has 6 things, and the first one that you always look for is that greatest common factor. All right, now this list is not a mandatory, you have to do it this way thing, but it's one of those, it's best to do it this way thing. So you guys have seen what the end of chapter 8 looks like. So as you go through one of those more complicated problems, first look for the greatest common factor, then look for whatever this is, okay? And kind of go in this order. If you go in that order, it makes it easier than any others. But we're only going to worry about greatest common factor right now. Okay. So let's look at something we know how to do. And this might not make sense at first while I'm talking about this, but I promise it will here in a little bit. And that is using the distributive property. Okay. So let's remind you what the distributive property is. So if I had something like 4c times the quantity of 2c plus 5, remember we watched our video about making that dirty hippie cry, 4c times 2c is 8c squared, 4c times 5 is 20c. Well, we're used to going from here to here. When we factor by the greatest common factor, we're going to start this way and work our way up. Notice, if you look at 8c squared and 20c, the greatest common factor of that is 4c. So instead of multiplying it in, we're going to find the greatest common factor and take it out. Okay. So let's start with an easier one. So this would be example 1. We have 8x minus 20. Okay. First, find out what the greatest common factor is. In this case, the greatest common factor is 4. So then you ask yourself, 4 times what gives you 8x? Well, that would be 2x. Then bring your sign over as minus. 4 times what would give you 20? That's 5. So now if I went back and used the distributive property here, 4 times 2x is 8x. 4 times negative 5 is negative 20. Okay, you can check your answer by redistributing that. And if you get the same thing you started with, you did it correct. Okay, let's look at another example. 9x to the 5th plus 15x cubed. Well, numerically, they share 3 as the greatest common factor. And then variable-wise, they share x cubed. 3 of them here, 5 of them there. So they share 3 of them. 3x cubed times what gives you 9x to the 5th? That would be 3x squared. And then 3x cubed times what gives you 15x cubed? That would just be 5. Example 3. We got 16x to the 4th minus 12x cubed plus 14x squared. Okay, I'm not going to have enough room to do that one to the side, so I'm just going to do it below. But now we want to look at all 3 factors and figure out what the greatest common factor is. Well, numerically, the biggest thing they share in common is 2. And then 4x's, 3x's, 2x's, so the most they share is 2. So now ask yourself, 2x cubed times what gives you 16x to the 4th? That would be 8x squared. 2x squared times what gives you 12x cubed? Would be minus 6x. And then 2x squared times 7 gives you 14x squared. Okay. I'm going to do a couple more of those. So example 4, we have 4x squared y to the 5th minus 9x cubed y. Okay, take out the greatest common factor. Well, 4 and 9 don't have any numeric factors in common, so there is no greatest common factor as far as the numbers are concerned. But we do have 2x's and 3x's, so they share 2 of them. 5 y's and 1 y, so they share 1. So this times what gives you this? That would be 4y to the 4th minus this times what gives you that? Well, that would be 9x. When you get done, there should be no common factors with the 2 or how many ever terms there are inside the parentheses. All right, and lastly, a 5th example. We had 10a cubed, b to the 5th, c to the 2nd, plus 35 a to the 4th, b, c to the 6th. Okay, here in common they have 5, 3 a's and 4 a's, so they share 3 of them. 5 b's and 1, so they share just 1. 2 c's and 6 c's, so they share 2. So now you got to ask yourself, this times what would get you back here? Well, that would be 2b to the fourth plus this times what would get you back here? 7a and then c to the fourth. So that's how you factor by the greatest common factor. And if you would have been there on the day that we did this, this is where we stopped on day 1. We went back and finished the rest of section 2 the next day. I'm going to go ahead and do the rest of it on this video. That way you have all of section 1 and section 2 together. So the last thing we're going to do is to factor by grouping. Now if we go back to our list, I don't know why I did that big line there, we had greatest common factor here, 2, 3, 4, 5, and 6 were all blank. Well, grouping is actually the last thing you want to try. It's the second thing we want to learn, but it's the last thing we want to try. So let's look at how to group. So much like we did last time, I'm going to start out by explaining this. Explaining this by something that you know how to do. You just learned it. So what we know that if you have something like 5xy plus 3y, well, we can take out the greatest common factor, which in this case is y, and we're left with 5x plus 3. Okay, that's the exact type of problem that we just did on the previous 5 examples. Well, what we must understand is that if I have this problem instead, 5x times the quantity of y plus 2 and 3 times the quantity of y plus 2, it can also be factored. Now, I used this 5x and 3 in the same spot on purpose, but what I changed was 5x times y to 5x times a quantity. What you have to be able to recognize is that this y plus 2 inside the parentheses is not two things. It is just one thing. Right? It's one binomial. So we are multiplying 3 things right here. 5 times x times the binomial. Over here we're multiplying 2 things. 3 times the binomial. Well, if we factor out the greatest common factor, they share this binomial factor. Just like they shared a factor up here that was a monomial, and we took out the monomial. You can also take out the binomial. So the greatest common factor is y plus 2. Well, this times what gets you back here. Take this quantity times 5x, and you get the same thing here. This times what gets you here, times 3. So it's the exact same idea as the one above, but instead of factoring out a monomial, you're factoring out a binomial. So understanding that's going to be critical to moving forward. So let's look at the first example of grouping. Okay, if I have 4x cubed plus 8x squared plus 3x plus 6, there is no greatest common factor. Okay, the only factors of 4 are 2's, and 3 is prime, so it doesn't go in. And that doesn't have an x term, so we have no greatest common factor. So what we're going to do instead is look at these first two terms and take out the greatest common factor of those two, okay? That's the first group. This is going to be the second group. This is why we call it grouping. So what's the greatest common factor of the first group? Well, that's 4x squared. So take out that greatest common factor, and you're going to be left with x plus 2. Look at the greatest common factor of the second group, 3x plus 6. That greatest common factor is 3. Now you have to put plus 3. You factored out a positive 3. You can't just put 3, you have to put plus 3. If you factored out a negative, you'd have to put minus 3. And when we factor that out, we're left with x plus 2. 3 times x is 3x, 3 times 2 is 6. Conveniently, x plus 2 and x plus 2. If that doesn't happen, you can't factor this way. That has to happen. You have to get the same thing inside the parentheses. So if you take out that greatest common factor of x plus 2, and now we have x plus 2 times what gives us this? Well, that's 4x squared. X plus 2 times what gives us this? That's plus 3. So there are the two factors that give us that cubic polynomial. The way you could check is you can multiply, go back to chapter 7, you can multiply these out. Use your distributive property twice, and if you did, you'd end up with this as your answer. Okay. Let's do another example. Example 2. We have 4r cubed minus 10r squared plus 6r minus 15. Okay, there is no greatest common factor. Yeah, you can tell real quick that doesn't have an r, so there's no variables. And then the factors of 15 are 3 and 5, 1 and 15. None of those go in 4. If something doesn't go into all of them, then there is no greatest common factor. So we'll take our first group, 4r cubed and minus 10r squared. The greatest common factor is going to be 2r squared. So we'll get 2r minus 5. Take the second group, your greatest common factor this time, well, I guess again is positive 3. And we're left with 2r minus 5. Again, if you get something different inside the parentheses, you're done. It does not factor this way. Take out the greatest common factor of 2r minus 5. And we're going to be left with 2r squared plus 3. Okay. What ends up happening is this one goes here and this one goes there. Got 2 more. So let's do those. Steph, are you down here? Can you go in that back bedroom? And I left a book, my algebra book, just to the left of the chair. Can you get that for me? All right, example 3. We have 20c cubed minus 15c squared minus 8c plus 6. Thanks. All right, we can't factor by greatest common factor, so we have to group again. Forgot to get your questions that I wanted you to do written down, so I'm kind of ad-libbing here. So the greatest common factor of this first group is 5c squared. So that gives us 4c minus 3. Now you have to be careful here, because remember, we want 4c minus 3 to be in the parentheses over here. But that's a negative and that's a positive. It's the opposite of these signs. So when you factor out a negative, In this case, the greatest common factor would be negative 2. Negative 2 times 4c gives you negative 8c. Negative 2 times negative 3 gives you positive 6. So you had to factor out that negative to get it to match inside the parentheses. And then we're going to get 4c minus 3 and 5c squared minus 2. All right, last one. Let's do 9w cubed minus 6w squared plus 3w minus 2. So this one has a slight trick to it. Greatest common factor is 3w squared, so we get 3w minus 2. Well, notice there is no greatest common factor here, and the 3w minus 2 matches what we want inside the parentheses. So the trick is to factor out a 1, because multiplying by 1 doesn't change anything. So factor out a plus 1, and then 1 times 3w gives you 3w, 1 times negative 2 gives you negative 2. If that would have been minus 3w plus 2, you would have factored out a negative 1 to get it to match. And then factor out our greatest common factor, which is the binomial of 3w minus 2, and we get 3w squared plus 1. Okay. So I'm going to give you some recommended problems from the book. And if you don't know how to do these, come into office hours or send me an email, and we can go over them. These are all going to be from section 8.2. Okay. What I would recommend doing is number 2 is easy enough. Number 8 is good. And 9 is good. And those are all like the first problems. And then maybe some other ones that I would do. I'm trying to find a specific one that I think would be good. Okay, I think I found it. Let's do 25. Let's do 43, and lastly 45. Okay. So if you can do those 6 confidently, I would say that you can do most any of them that are like the basic ones of this type. Okay, so try those 6. Maybe you can email me your answers, or jump on to office hours and you can tell me what your answers are, and we can fix any mistakes that you might have. So that's section 8.1, section 8.2. I know I kind of got this to you a day late. I apologize for that. I look to get section 8.3 either up today, which is Tuesday, or tomorrow, Wednesday. See you guys.